Okay, for this video, we'll be going through the specimen paper for your 5086 paper 1. Okay, let's start. Question 1. A student uses a stopwatch to time a runner running around a circular track. The runner runs 2 laps, okay, around the track. That means twice around the track. The diagram shows the reading on the stopwatch when the runner starts running. So, of course, it starts when it's 0. Okay, and then at the end of the first lap. So, this is the time taken to finish one lap. We notice that it is 1 minute and 13 seconds. So, 1 minute is actually 60 seconds. So, total, he took 73 seconds because 60 plus 30 is 73. The reading at the end of the second lap is actually 2 minutes, so it's 2 times 60 plus 3 seconds, so it's 123 seconds. So they are asking what is the time taken for the runner to run the second lap. So basically he took 123 minus 73 equals to 50 seconds. Okay, so answer is A. Okay, a student measures the velocity of a trolley traveling in a straight line. At one instant, the velocity of the trolley is 1 meter per second, and 2 seconds later, velocity is 4 meter per second. What is the acceleration? So we have to find the A. A equals to V minus U over T. So the final velocity is 4 minus initial is 1 over a duration of 2. So we will get 1.5. So answer is A. Passenger is sitting in an aeroplane which takes off and climbs to 10,000 meters in a certain time. During this time, what happens to the mass and to the weight? So this one is easy. The mass is unchanged. The weight actually decreases. Because weight is W equals to mg, right? While the mass remains constant, the g actually decreases as it's further away from Earth. Okay? What are the conditions for equilibrium? There are 2. One is resultant force acting, no. Resultant turning effect, no as well. So answer is A. Okay. So this is answer C. Okay, to prevent a cement mixer sinking into soft ground, the mixer is placed on a large flat board. Why does this prevent the mixer sinking? Okay, so basically the weight does not decrease because it's the same weight, right? The weight does not decrease, or the weight does not change. Now pressure equals to force over area. Now since the weight is constant, but now it is over a larger base area, so the pressure will decrease. So this is A. Okay. Okay, a bungee jumper has jumped from a bridge and falls with increasing speed. That means the KE is going to increase, but because it's falling, the GPE is decreasing. Okay, and before the cord begins to extend, that means before the cord extend, what is happening is GPE decreasing. It is being transferred to his KE. Okay, so answer is C. A man weighs 600 Newton. He runs up a staircase of total height 4 meters in 3 seconds. So this is his weight. Now, how much power is needed to do that? Power is equals to energy over time. So work done over time. So it is force times distance moved over time. And because we are using weight, which is 600, and the height over 3, so it will be 800 watts. Okay, so answer is B. A quantity of gas is trapped in a container by a frictionless piston. Temperature of the gas is increased. That means the gas is going to expand. So this is correct. Now this is very wrong. The molecules cannot get bigger or smaller. It is always the same size. So that's why this is a common mistake. Okay, question 9. I see a lot of wave fronts. Okay, so it is to count the gaps. Count the gaps. So the distance between the 2 cracks shown is 20 cm. That means I have 1 gap, 2 gap, 3 gap, 4 gap, 5 gap. That means the wavelength, I total have 5 wavelength. That is 20 cm. So each wavelength is 4 cm. Now I have frequency of 4. So V equals to F lambda. My V is frequency multiplied by lambda, the wavelength. So I get 16 cm because it's in cm per second. So answer is C. Now which group contains only transverse waves? So I'm looking out. I cannot have sound wave. So A is wrong. I cannot have sound wave, sound wave. That means answer is B. Okay. Okay, sound wave is longitudinal. Okay, radio wave has a wavelength of 1,500 meters and travels with a speed. So what is the frequency? So again, using this formula, V equals F lambda. 3 times 10 to the power of 8 equals to frequency times 1,500. That means my frequency is going to be, hold on. Okay, so answer is C. Okay, 2 times 10 to the power of 5 hertz. Okay. Now, a hospital needs to sterilize medical equipment. Which EM wave could be used? This must be ultraviolet. Okay. The current in an electric heater is 10 ampere I. It is switched on for 5 minutes. Be careful, this is a trick because we will need to use the time in SI unit of seconds. Okay, so how much charge flows through the heater? Basically, Q equals to IT. It is a SI unit formula. So charge is Q. Okay, I is 10 multiplied by 300. I'll get 3000 coulombs. Okay, so answer is D. Circuit contains 2 resistors connected in parallel. Which of the following statement about the currents at P, Q, and R is correct? I know current R is equals to IP plus IQ because in parallel, the current is sum. Okay, so current at P is the greatest. That is not true because current at R should be the greatest. So answer is C. Okay, now which one is bigger, IP or IQ? IP is bigger because it has a smaller resistance. They have the same potential difference. V equals to IR. If they have the same V, and because RP is big, RP is small, IP will be big. If we compare Q, V equals IR, Q, V is the same across these 2 resistors, right? In parallel, the potential difference is the same. So if RQ is big, right, versus RP, so the current must be smaller. So it cannot be the same because IR is the sum of P and Q. Now, diagram shows a circuit. The resistors are connected in a series. So the current is 0.5 ampere. And this has negligible resistance. What is the resistance of resistor R? Okay, so we can do this. V equals to IR. Because they are in series, I can add up the resistance, which is 1 plus R. And the V is 3. Okay. So 3V equals to 0.5 plus 0.5 R. That means my R is going to be 5 ohm. Okay. So let me check. What if my R is really 5 ohm? So I will draw my circuit like that. 5 ohm and then 1 ohm and then my 3 volts. So this will actually become a resistance, equivalent resistance of 6 ohm, 3 volts. And if I do that, then the current will be 0.5 ampere. Okay, so this is another way to do it or to check. Now, electric heater is rated at 3 kW. So this is the P, and it is 3 kW already. So that means they are going to calculate the cost, right? Consumer is charged 20 cents per kWh of energy, not per kW, it is per kWh. Okay, so this is the cost for every kWh, which is basically your energy. Okay, what is the cost of using the heater for 5 hours? This is T. Now, energy equals to power times time. So my power is 3 kW. My time is 5 hours. So altogether, I have 15 kWh. So if 1 kWh is 20 cents, 15 kWh will be, just a second. Okay, I will get, because 1 kWh equals 20 cents, 15 kWh will then be 15 times 20, I get 300 cents. So answer is D. Okay, so every time they ask for money, cost of electricity, always express your energy in terms of kWh, which is power in kW, time in hours. Okay, now 70 many electrical appliances have metal cases, okay, to prevent the case from being live. With the possibility of an electric shock, earth wire of the electric cable is attached to the case. How does the earth wire prevent an electric shock? It allows the current to flow to earth so that the appliance continues working. Okay, maybe. It allows the large current to flow to earth, blowing the fuse. Yes. Okay, this one, yes. It prevents the fuse from blowing. No, because when we have when the case is live, somebody touches it. Oh no, when the case is live, the current will flow through the earth wire. It will be a very large current. It will be a large current. Okay, therefore it will blow the fuse. Then we'll know that there's an electrical fault, because when the fuse blows, right, then the thing stops working. Okay, appliances stops working. Then we know that there's something wrong with the appliances. Okay, so this one, A, is wrong because the appliances continues working, which is false. Okay, yeah, so answer is B. So usually earth wire, they are in your 3-pin plug, correct? Earth wire and 3-pin plug, they always have a fuse. Why? Because they work hand in hand. Okay, 4 plotting compasses are placed. Which one shows the wrong direction? If this is south, yes, the compass direction follows direction of magnetic field. Okay, and it enters south, right? So it comes out from north. So A and B are correct. Now, so D is incorrect, C is correct. Okay, so answer is D, because we are looking for wrong direction. Now, 2 parallel vertical wires P and Q are small distance apart in air. There's a downward electric current in both wires. So whenever there's an electric current, it will produce magnetic field. Now, because both will produce magnetic field, so 2 magnetic fields are produced and they will interact. Okay, they will interact. A force acts on Q owing to the current in P, right? It's actually more because more due to the interaction of the magnetic fields. Okay, the force is perpendicular to the direction perpendicular to wire Q. What's the direction of the force on Q? Okay, so in this case, I would need to know. Okay, so this one is a bit tough. I need to use my Fleming left-hand rule. Okay, it's either I use Fleming left-hand rule or I use the interaction of the magnetic fields. Okay, so this is the current. So you'll use your middle finger of your left hand. Okay, because we are using Fleming left-hand rule. Okay, then for P, the current will produce a magnetic field. So because this is a straight wire, so I will need to use my thumb to represent current of P. So I will use my right hand grip rule. Okay, right hand grip rule for straight wire, with the thumb representing the current's direction in P. So if I do that, okay, my thumb is actually pointing to the bottom of the screen. So over here, the magnetic field is entering. So coming out, over here is coming out. So this will be the external magnetic field. This is produced by P. So this is the external magnetic field for Q. Okay, it's not produced by Q. This is going to be my external magnetic field direction for Q. Okay, so with that, the direction is A. Okay, so this one is tough, needs more time. But if I were to look at it from the top, okay, I would see P current going away from my eyes. So it's a cross. So this is IP. I will see Q's current. If I were to look from the top, I will see them leaving. Okay, then I apply my right hand grip rule. Okay, and the magnetic field for Q will be this way, this way, this way, this way. Okay, for P will be the same direction, like that, will be the same pattern, yeah. Okay, apply your right hand grip rule. So over here they actually cancel each other out. Cancel. So there is zero magnetic field here. There's one here, there's one here, because nothing to cancel them. So the magnetic force always goes from more magnetic field to less magnetic field. So that's why for Q, it will be direction of A. So there are two ways to do it. Okay. Now, last question. Half-life of the nuclide radium-225 is 15 days. That means every 15 days, the number of nuclide will decrease by half. Pure sample has 16 grams. That means after one half-life, it will become 8 grams. Okay, one more half-life, it will become 4 grams. One more half-life, it will become 2 grams. So actually, how many half-life has it gone through to become 2 grams? 3 half-lives. Okay, 3 half-lives. Okay, VS. Okay, 3 half-lives. So each half-life is 15 days. So 3 half-life, it will be 45 days. So answer is A. Okay.